So we use oxidation numbers to identify redox reactions. If the oxidation number increases, an oxidation has occurred. If it decreases, reductions occurred. If there are no changes in oxidation numbers, it is not a redox reaction. Let's look at the first example. Here we have hydrogen gas reacting with iodine gas to form hydrogen iodide. If we work out the oxidation numbers, which they've already done for you here, we can see these are both elements, so they both have an oxidation number of 0. When you then work out what the oxidation number is, hydrogen has got +1, iodine is -1. That's just based on our rules. Remember, hydrogen is always +1, so iodine needs to be -1 to balance out that charge. So the oxidation of hydrogen has increased. It's gone from being 0 to being +1. Thus, the hydrogen has undergone oxidation or been oxidized. The oxidation of iodine has decreased. It's gone from 0 to -1. Thus, if it's decreased, it's undergone reduction or been reduced. It's therefore a redox reaction because there has been a change in oxidation numbers. Something's been oxidized, something's been reduced. Okay, here's a good example question which is from the very start of the video. The metal is obtained from tungsten oxide by heating it with hydrogen gas according to the equation as shown here. Using oxidation numbers, determine whether this equation represents a redox reaction, and if so, identify the oxidant and the reductant. Using oxidation numbers, determine whether this equation represents a redox reaction, and if so, identify the oxidant and the reductant. Okay. So here I've copied another one out of the textbook, and it's already worked out your oxidation numbers for you, but if you won't work them out, it's exactly the same as we've been doing. Oxygen here is -2, there's 3 of them, so tungsten needs to be +6. Here it's an element, so hydrogen has an oxidation number of 0. Here, tungsten's the element, it's got an oxidation number of 0. Oxygen always -2, hydrogen +1. So, we can see from this straight away that the oxidation of tungsten has decreased. Tungsten's gone from +6 to 0. So this compound has been reduced, because its oxidation number has decreased from +6 to 0. The oxidation number of hydrogen has increased. Hydrogen has started off with an oxidation number of 0, and now it's got an oxidation number of +1. So the oxidation number of hydrogen has increased. Okay, the first thing you need to do is assign oxidation numbers. It's exactly what we've been doing. So oxygen is -2, -2 times 3 is -6, so tungsten needs to be +6. Hydrogen is an element, so it has 0. Tungsten is an element, it has 0. Hydrogen, always +1. Oxygen, -2, except for those exceptions which are really rare. We just double check here. 2 times hydrogen is +2, -2 equals 0, which is the overall charge of water. Fabulous. Now it's quite simple to see what's going on. So, the oxidation number of tungsten decreases. It decreases from +6 to 0. So, this compound is reduced. It's had a decrease in oxidation number, +6 to 0, so it's been reduced. The oxidation number of hydrogen increases. Hydrogen goes from being 0 to being plus 1. So it's increased, so hydrogen has therefore undergone oxidation. It's gone from 0 to plus 1. Increase in oxidation number means oxidation has occurred. The reaction is therefore a redox reaction because both reduction and oxidation has occurred. Just take note, it's actually tungsten oxide, not just the tungsten there that's been reduced. It's the whole compound that's involved in that reduction.